Periodic trends. It's the arrangement of the periodic table. The arrangement of the periodic table. Means that the physical properties of the elements follow a regular pattern. We can look at the size of the atom. Size of atoms, atomic radius, or their atomic radius. So, there are two trends for atomic radius. Two trends for atomic radius. So we'll define those trends, how it, going across and everything. So let me draw that in the next slide, and then you guys define those two trends, alright? Then we'll define those two trends in this periodic table. So let's say group 1A, 2A, 3A, 4A, 5A, 6A, and 7A. Now when we draw lithium, beryllium, boron, let's draw a little bit, carbon, nitrogen, oxygen, and fluorine. And when we go down here, this is cesium, rubidium, potassium, sodium, you can see magnesium, calcium, so let's say so and so forth. When you define the trend, by looking at this picture, when you go down from here to here, left to right, what happened to the atomic radius?
It got smaller.
It gets smaller, right? So atomic radius decreases. And in your book, it's numbers also given. The atomic radius 0.152, 0.111, up to the last fluorine is 0.064. So when you go this way, it decreases. Then you go down, what do you think? What do you see here? It increases, right? So, and this trend applies to the main groups only, not transition groups, but just a main group. So let's define together. What are those two trends? Atomic radius again. Decreases as you go up a group, or here it's saying go up. When you go down, it increases, right? So however you want to define. Second, atomic radius decreases as you go left to right across a period. And this applies to the main groups. So I'm going to write that here somewhere, that this applies to this trend, applies to main groups, A groups. Not transition. Transition group. So that's the first one. Now we need to find out why it's happening, why the radius is going across, it's going to reduce, and going down, it's increase. So let's find why. So let's go to next page. Atoms get smaller as you go bottom to top. On the periodic table. Because as you travel up a group, there are fewer energy levels. Fewer energy levels on the atom. So let's see. Well, we'll see the sodium. Okay, so we say, okay, sodium. Then when we go there, you can see hydrogen, sodium. All right, lithium, sodium, potassium. Let me write that. Let me write, lithium has 3 electrons, right? And when we write electronic configuration is 1s2, 2s, 1, right? Now sodium has what? 11 electrons, and when we write 1s2, 2s2, 2p, 6, and 3s, 1. So you see that the energy level here, 2 energy level. This is 3 energy level. When you go down to the other elements, the energy level increase. 4s1, 5s1, 6s1, like that. Sorry. See, energy level increase. That means there is a nucleus and the energy level increase when you go down. It's like layers increase all the time. If layers increase, what happened to the radius? Yeah, but when you go down, it's increased. When you go up, it's going to get smaller, right? So that's the first one. Why it gets smaller? Because because of the energy levels. All right. Now let's see about another energy level. Let's say atomic radius. Decreases as you travel left to right. And the question is why it's happening. So we'll say it's across the periodic table. Now question is why? Because the number of protons in the nucleus increases. And as the number of the proton increases, the nucleus pulls electron. Pulls electrons closer towards itself, and it reduces size of the atom. Alright, so let's say the first group or first we say lithium, and then it's what? Neon, right? Now when you see this has 3 protons, this one has how many protons? Neon has how many protons? 10 protons. Now they have the same energy level. They have the same energy level, right? Or different? They are different? Okay. So in the second one is what? What's the Nobel gas for the second period? Neon, right? So that's right. So they have the same energy level. Now what happened? See the center, in the center it has a 3 proton. The pull on the outer electron is less compared to here. There are 10 protons. The pull on this outer electron is more. Why? Because 10 protons are pulling electrons towards itself, right? When there is a more pull, the atomic size decreases. Alright? And that's what is happening. They pull the electrons. Number of the proton increases, nucleus pulls the electron closer. So that's why neon has more pull, so that's why atomic radius smaller than this one. So that's why this strand is getting what? From left to right, its atomic radius decreases. So that's atomic radius strands in periods and groups.